Hi, welcome back. In this video, we're going to talk about constant velocity. I think this is a pretty easy topic, so I'm going to go through it fairly quickly. So if you're feeling pretty confident with it, you might want to just skip ahead to the problems at the end. But I'm going to go through some of the basics just in case you missed them in class. So while these are both words that you've probably heard before, speed and velocity, in physics, they have different meanings and we have to be careful with which one we use. So really fast, the difference between them is speed is simply defined as how far you travel every second, or another way that you could write that would be, we would call how far you go delta x, or your change in position, divided by time. And for velocity, it's really the same thing. The only difference is it also has a direction included with it. So an example for a speed would be something like 5 miles per hour. But if you wanted to have a velocity, it would have to be something like 5 miles per hour east or west or up or down or something like that. So velocity is simply more specific than speed. And in physics, 9 times out of 10, we're going to go with velocity. Speed is not as useful of a idea in physics as velocity, although we'll talk about speed sometimes. But just make sure you understand the difference. This is going to be the language that I use in these videos. And since we're going to be talking about velocity so much, it actually turns out there's two very different ways to talk about it: average velocity and instantaneous velocity. So in physics, when we talk about an average velocity, what that's really referring to is how far you went in total divided by the amount of time that the trip took. Usually when people are talking about velocity who don't really know their physics, they're talking about this. Instantaneous velocity, on the other hand, is how fast you're going at that particular moment in time. On some problems, these two values can be incredibly different. Let me give you an example. So what I have at the bottom of the screen here is a position versus time graph, where this axis tells you how far you've traveled. We use X or Y to denote how far you go, and that's measured in miles. And this axis measures time, how many hours have passed as you travel. And you can make a nice graph to show really any person's motion that you want. So in this particular case, it's a little interesting because there's one motion that I showed in white, and then there's a very different motion in yellow. And before I even tell you, you can probably already draw some conclusions about the difference between this part of the trip and that part of the trip. But we have to be very careful with how we use these two different types of physics language to describe this trip. Now, if you want to actually calculate these values from a graph, it's very simple. To find average velocity, you simply find the slope of the entire thing for the whole time interval. And for instantaneous velocity, all you need to do is find the slope at a particular moment in time during the motion, and you can get two very different answers for it. So if we look at this graph at the bottom, the white line shows that we started at position 0 when time was equal to 0 hours, and then over the course of 1 hour we traveled 15 miles. Well, that's 15 miles per hour. So for this part, I would say that the instantaneous velocity is 15 miles per hour. And then for the yellow part, I'm sure you're good enough at math to handle this. At 1 hour, we were at 15 miles, and then we traveled, well, to find the slope, it's rise over run, right? So we traveled 10 miles. We went from 15 to 25, and it took us 4 hours to do it. So if we went 10 miles in 4 hours, our instantaneous velocity here is just 2.5 miles per hour. And notice we have a much smaller slope at this location, so we get a smaller velocity to go along with it. Now, what about average velocity, though? What was your average velocity for the entire trip? Well, to calculate that, you simply look at the beginning and the end. It doesn't really matter whether you got stuck in a traffic jam or not, or that sort of thing. Whoops, straighten that out a little bit. You get the idea. But if you draw this line from start to finish, then over the course of this time, you traveled 25 meters, and it took you, or I'm sorry, 25 miles, and it took you 5 hours to do it. So we would say that your average velocity for the entire trip, your V bar, was 5 miles per hour. And that makes sense. For some of the trip, you were going 15 miles an hour, and some of the trip, you were only going 2.5. It would make sense that your average velocity